Hello everyone, this is Bradley. So today we're going to use geometry nodes to do this kind of a spaceship animation. Note that in the past I've using animation nodes and shape keys to do this animation. However, as you know, the geometry nodes currently do not support such kind of function for shape keys. So today we're going to use a kind of workaround to mimic such kind of effect, which I think should be doable. The only thing that I find probably tricky is the color. In this case, I do not want to really investigate too much about that, so we will just skip that for the moment. So let's start. The most important part is actually the modeling, and I'm going to model with shape keys. So I added two modifier, and I'm going to add a subdivision surfaces because I want to smooth them out instead of having any kind of troubles later. In this case, I'll probably just keep that as a sphere. No, I'll probably, yes. First thing I'm going to do is to add several loop cuts and cut it here. Make it a cube like this should be good enough, and add a cut here. Okay, so note that now everything we're working on is key 1, is the basis, and then we're going to move with key 1. Okay, within key 1 I'm going to do several things: extrude, and shrink, and it's always important to check the original state. Okay, so when we have this, there's really not much I can say about the modeling. Just model whatever you want. After all, this is just a kind of really a test instead of the actual something that should be good enough. We can add more loop cut later, but I want to check if the cube is still like a cube. Okay, so this is fine. I'm going to duplicate this mesh in case I made any mistakes later. Now this is too kind of smooth out, so I would like to add several loop cuts. Yes, the cube is still cube. So that's the most important thing. Okay, something like that should be good enough if the cube is still cube. Yes. Once we model things like this, I think it should be completed. It's not perfect, but I will just buy it. And then we take the mirror modifier and bisect that. So we remove all the intersection. If there is not any problems, then we'll move on to the next step. I think I'm going to move this to make it a little bit flat so that it's not too fat. Okay, so now this really looks kind of okay, at least to me. By the end, it depends on how you model this. So we have these two shape keys. What I'm going to do is to duplicate this, and I would say this is spaceship A, the other is spaceship B. Okay, I'm going to. So now we have the spaceship. I do not know the method to really apply the shape keys. Maybe you know, but I don't know. I do not know. But I don't think it does really matter. If we take the key ones and smash that to 0, then we have a cube and a spaceship. Essentially, they're the same mesh, just with different shape keys results. And here, I'll probably just put them into the height. I need to create a new object that holds the geometry node tree, and then goes to the geometry nodes editor. Frame more to see our node trees. Probably take a fake user. Okay. Once we have this, and I'm going to take the object info of a SA and SB. So SA and SB. So if I look at the SA, it's a cube. If I look at SB, it's a spaceship that we just modeled. Next thing is to really doing the basic shape keys within geometry nodes. So let's set the position. So geometry into geometry. So now we have a cube, but if we try to make a kind of a transition, then we always use either mix RGB or mix vector nodes. Okay. Here, the base form should be the position. So the original location coming from our SA. So basically, since this position is finally linked to this geometry, then the position actually means the vertices location from our SA geometry. So this is how it works. Okay, next thing is we're going to take the attribute transfer. It's because you cannot put the locations within the position data. The attribute capture also won't really work because it just won't work. And we take the index, take the vector, take the vector. geometry into targets, put the position into the attribute. So this position is linked to this geometry. So this linkage actually means the vertices locations of SB. So the whole point of all these kind of built-in attributes is they do not really carry data by themselves. They only output data based on the contexts, which means you have two linkage, and the two linkage can really mean completely two different things. Okay, and once we take this vector, I think I'll just mix that. And since we are doing the index transformation, so the first vertex will morph to the first vertex, the second vertex will morph to the second vertex, and so on and so forth. And SE and SB, they're essentially the same objects with different shape keys. That's why there's such kind of smooth transition that's been going on. So this is actually good. So now we finished the single units. Next step is to distribute, to create a kind of points so that we can instance the whole setup in later. And fortunately, we actually has already kind of a plane being generated at the most beginning to hold this geometry node tree. I'm going to distribute the points and take that to Poisson disk. Poisson disk is essentially to avoid all this kind of intersection, so that if you turn on this minimal distance, then we eliminate this kind of points which are too close to the other points around. So here, just a little bit should be fine. And I'm going to take this plane, maybe increase the size by 2 so that we have more points. And of course, they are not already overlapping to each other because of this Poisson disk. Otherwise, you can also increase the distance a little bit so that more points being eliminated and more points are very far apart from each other. So these are just the kind of things that you can potentially manage in your free time. So take a set of position. I'm going to first make a kind of a delay to make them to fly up. So we take a vector mass. So here are several things. Usually the position has an automatic input with the position attribute. That's why even without the inputted positions, they stay at the same locations. But if you add a vector mass, then everything has been crashed to the point 0, 0, 0 plus 0, 0, 0, which is essentially the world origin. That's why you do not see anything. However, so in this case, you need to add a position normally. However, with the new updates, we have these offset options, which means even if you do not add anything, if you enable this offset, it will automatically add the positions inside your end product from this vector. So this is the idea. So in this case, it just save the one more node of the position linkage, and we can directly apply the scale to 1. I'm going to add one randomness to all this kind of end result. So let's take a random value and combine it to z. Values to z and take the ETD. Yeah, we do not need to input ID because this is also automatic. So take the vector into vector, then immediately we have this random height for each different kind of points. I think this will just be fine, so I will just stay as it is. Next thing is I'm going to add a delay for. You can download the preset for free from the link in the description. Put the values into the scale, then everything goes to the resting positions. But by increase the time, then they will just fly up. And they fly to the infinity because this values is not being clamped unless you hit a clamp to 1. So now we have kind of delay for different points is being flied at different scale. And there is a step interval, you can take the 1. Also there is variances, I'm just going to take the 0.5, so that 50% variances. Okay, so now everything is kind of cool. Next step is to create a second wave of animation that's after they fly up, they would like to move on the y-axis towards me. So I'm going to take a add vector and by moving to the negative y, it flies towards me, right? In this case, just to take one more scales at the -1s. Here I'm going to take a new delay fall. So I need to control the time, so let's take a time info divided by 10. So basically this is the time inputs that's controlling basically all the animation, right? So if I put a kind of subtract the time, maybe minus, so subtract 1, then there will be an interval from this animation to this animation. So put these values into scale. This time I'm not going to clamp, I'm just going to set to 1000. So that we will actually see the effects. So it flies up initially, and then after the stop, then they start to move towards me again. So this is the idea. You can also definitely ease the animation, but I realized one problem is that you need to color ramp. Did I clamp this? Yes, if I clamp these, then it will be fine. The issue of the color ramp or any kind of curve, RGB curve or float curve, is that it will clamp all the values from 0 to 1. So this is very bad specifically for this particular fall, because our value is supposed to go up to 1000, but we can definitely clamp that, and then mass values multiply to 100. So now we see the animation, and then now it actually flies too fast. But I think you get a kind of, you can imagine kind of ideas. I'll probably fix that in my free times to improve the presets. But currently, so initially we just have, yes, this is how it works. Okay, so now we have completed the basic animation of our points. So we can start to instance our animation that we have created at the most beginning. So basically this group. But one thing you also notice that currently the instance do not really carry any attributes. So they are really the kind of mirage. You cannot really access the mesh points or the vertices, edges, faces, nothing from the instances. In this case, you have to realize the instances. But if you realize the instances, everything, all the kind of objects has been converged into vertices, edge, and faces. So you do not really distinguish from instances to instance anymore. In this case, we're going to change the order of working. So here I'm going to put in geometry into instance, and I'm going to instance again with SB. And here, let's use the same value to control the scale. So maybe decrease the scale. Okay. Once we have done this, you can see that originally we have 106 instances, but later everything just becomes a single mesh that contains 500k vertices and more edges and more faces. In this case, let's realize the instances for both of them. And then I'm going to set a position. And transfer our SB instances position into the first one. Once we have done this part, then it seems like we replicate the same animation. So what's the point of doing the order differently? It's because if we can actually put a different factors into this place. For example, let's take let me think. So we can take the directional fall and take an empty we also need the position as a factor to evaluate. So now immediately we can see anything which is on the right side of x-axis will be transformed into spaceship. The left side will be kept as ultrasound cubes. So here, let's make it better. What we can do is to increase this value to 1, so that all this kind of transition is essentially depends on the y-axis. Okay, and you can actually reverse the order, so that once they pass the certain points, then they will be the spaceship. Otherwise, they will be kept as cubes. Up to now, we basically finished everything that we can do, because the reason we're using this realized instances workaround is because the instances cannot contain any attribute for the moment, which also means that we cannot really transfer the attribute to our instances or to the factor. The whole point is that I have delay false values earlier, but this false value cannot be transferred across the instance stage. So this is kind of a tricky moment. There is essentially also workaround to finish that, but yeah, that's another story. So here I still would like to do something looking like this kind of transition when it's going across, going above the sky. So in this case, I think what I'm going to do is that I'm going to take a mass value. So take it 5. So for the entire spaceship will goes from 0 and then being lifted for 5 units. Okay, and in the meantime, we can use this directional force to actually trigger the z-axis animations. So this is how it works, and you can see below it's the spaceship, above it's a square. We're going to reverse that, so take the minimum and the maximum reversed. Okay, and there's also possibility that you rotate your z-axis so that they will be, how should I say? So let's not using the spheres because I would like to see the axis. So that's because we are evaluating the axis, which is index 2. So once it goes across that line, everything becomes spaceship. So I think this is going to work. So you can see the spaceship. And I would say this is it. I'll probably just end here. And the rest I will tweak by myself and probably update these many presets, because I realize there are many things that you can potentially do more with these presets. So I hope you enjoyed this tutorial. I'll probably see you next time. Bye bye.